This is a 2002 rack server by Sun Microsystems, the SunFire V120, a compact entry-level server intended to run Sun's Unix operating system Solaris. Let's get it back to life. Obsolete computer technology is my passion. I'm the vintage collector, and these are my stories. Sporting a whopping 512 MB of RAM, a single 650 MHz UltraSPARC 2E CPU and up to two 36 GB SCA UltraSCSI hard drives, these servers may look laughable from today's point of view. But back in the days, Sun Microsystems, which had been acquired by Oracle in 2010, had a strong foot in the workstation market. Taking influence from the Berkeley RISC design, SPARC, a short for Scalable Processor Architecture, was developed by Sun Microsystems throughout 1986 and released in 1987. Originally producing workstations based on the Motorola 68K platform, Sun then swiftly switched over to their own SPARC architecture. Besides of their use in computational and scientific applications as well as for software development, SPARC-based workstations like the Creator series also provided for graphics design capabilities, putting Sun into direct competition with Silicon Graphics. Powerhouses like the Sun Enterprise 4000 servers, later the Sun Enterprise 4500 and eventually the SunFire 3800 had a long-standing tradition in Pixar as render farms for movies like Toy Story, A Bug's Life and Toy Story 2, just to name a few. Even so, it's over 20 years ago, but imagine 250 Sun Enterprise 4500 servers providing for an overall of 3500 CPUs, 50 TB of storage and 3.5 TB of RAM in 2002 to render Pixar's Monsters Inc. movie. That's superscalar high-performance computing, which of course is beyond this compact 1-unit rack-mount server here, which was intended for other, more lightweight tasks. Sun clearly saw these machines for use in high-density data centers across many industries, although with a clear bias towards telcos and service providers, making them suit for running as firewalls, DNS servers, load balancers, and also web servers. For the latter, it shall be mentioned though that Sun at the time also had a competing lineup suit for hosting, the x86 Cobalt rack servers acquired from Cobalt Networks in September 2000. And whereas the Cobalt machine ran a heavily modified version of Red Hat Linux, traditional SPARC-based servers and workstations ran on Sun's proprietary operating system Sun OS, originally derived from 4.3 BSD. With release 2.0 coming in 1992, Sun OS was based off Unix System 5 Release 4 and rebranded to Solaris, eventually seeing an x86 version of Solaris with release 2.1 in May 1993 as well. At the time when the SunFire V120 came out in 2002, Solaris 9 was current, and that's what I'm going to install today. But first let's look around this pizza box machine, which on the front side features a standard type IDE CD-ROM drive and the system configuration slot, but more on that one in a moment. Behind these grills sit two UltraSCSI hard drives, which thanks to the SCA connector are fully hot pluggable. This system does, however, not come with a built-in RAID controller, so one would probably want to use software RAID using Solaris's Logical Volume Manager for resiliency.
Why not use a hardware RAID controller?
For one, because for traditional Unix machines, it was very common to use logical volume managers for managing RAID, and for second, because the SCA connectors are soldered directly onto the system planner, so it's not possible to simply rewire it to another controller unless you tinker around with a soldering iron. And if you're into tinkering, then why not join today's episode sponsor PCBWay for your electronics design and 3D printing projects. Right now, PCBWay runs their 7th project design contest, with project submissions still open till January 19, 2025. take your chance to win attractive prizes. As mentioned, these boxes originally came with 512MB of RAM, but this one had been upgraded to a whopping 1.5GB, although obviously by using third-party modules coming from Compaq. And while it is never 100% safe, but having a close look at the capacitors before powering up is always a good thing. At first glance, I see no visible corrosion and also no bulged capacitors. Coming back to the CPU, here we see the small fan with the duct intake that blows directly through the CPU cooler. Again, this is a 650MHz UltraSPARC II CPU. Now it won't be serious to compare this against, let's say, a contemporary Xeon or Pentium CPU, as the former is based on a CISC architecture where the SPARC is a RISC architecture. Said that, if anything, its competitor would be the Xeon as a workstation or server processor. However, not a fair match, as for one, the netburst-based Xeons of that period were built around a 32-bit platform, supporting between 512K and 2MB of L2 cache, whereas the SPARC V9 architecture, released in 1993, was a 64-bit architecture, and the then current UltraSPARC IIe supporting up to 8MB of L2 cache. Intel Xeon ultimately became 64-bit aware in 2003, eventually upping the L2 cache to 4MB. Still, I was searching online if I would find some benchmarks that would at least serve as an illustrative example on where to put the UltraSPARC IIe as a general direction. This one here focused mostly on a calculation on molecular dynamics and actually includes contemporary UltraSPARC IIe and Xeon CPUs. Again, treat this with care, as you can't directly compare different CPU architectures. But given it's the same calculation model used, it at least shows which CPU would be better suited for this particular use case scenario. Coming back to the hardware, I'm once again in love with how much tidied up these Sun machines are. There's not much room for expansions in this compact pizza box, but you can add one PCI expansion card, say for yet another SCSI controller or a network card. Besides that, everything is very well thought of and just neatly blends together, like as well up here for the card reader and the CD-ROM drive, which we will learn in a moment will need to be swapped out. And I particularly like this integrated quick reference found on the backside of the machine's cover plate, which also gives away that this very same mainboard was good not only for different CPU speeds, but actually was used one-to-one in the Netro 120 machines as well. On the backside, the machine offers a non-redundant power supply, 2 serial ports, 2 Ethernet ports, 2 USB ports and an extra ultra-wide SCSI port. As typical, it doesn't have a graphics port, as Sun servers, like many other typical Unix servers, didn't feature graphics hardware by default. The means of installing these machines is via a serial console. This is where the one labeled LOM comes into play. LOM is short for Lights Out Management and provides an always-on console for performing any kind of system maintenance activities. To connect to it, you basically just need a USB to RS-232 adapter and a serial cable. For Sun machines featuring RJ45 serial ports, any cable with the Cisco-style RS-232 to RJ45 rollover pinout will do. Once connected, I'll simply fire up my serial terminal app. The LOM provides a built-in help with all available commands and allows to remotely turn on the system using the power on command. Of course, as I'm sitting just beside, I could have reached out to the physical power switch instead. In a data center, these machines will normally be wired up to a serial console server like a Cyclades, from which you can connect to many different serial ports over SSH. Back to the Sun, I do spot immediately that something's wrong here, as the LOM reports a fault with the SCC and the amber fault LED is lit up. Now, the SCC is this thing here, the system configuration card, which contains, as the name says, some system configuration information. And although it's secured with a cable strap, it may have become loose, so I'm about to remove and reinsert it to see if it fixes the problem. Well yeah, that did the trick as the error went away. It's actually a known issue with these machines. So I'm good now to install Solaris 9. All what's needed is to insert the CD-ROM and type boot CD-ROM on the prompt. And while it seemed to work, I noticed the ultra slow loading speed, and even so I would ultimately end up at the disk partitioner. It prematurely bailed out. And from this stage onwards, I couldn't boot up the system anymore from the IDE CD-ROM drive. I guess the drive has a fault which caused read errors and thus the premature exit from the installer as well. After a few more tries I gave up on it. I guess I'll need to organize a suitable replacement drive. However, as these machines have an external SCSI bus, it's no big deal to connect a SCSI CD-ROM drive. On the LOM, you can run probe SCSI, which probes the internal SCSI bus, or probe SCSI all, which is what we want here, to also probe the external SCSI bus. And there it appears, the Pioneer CD-ROM drive. Now, I don't want to deal around with those cryptic device identifiers. By default, LOM supports def aliases like CD-ROM, which can be mapped to those device identifiers. As I want to keep that one, I simply defined a new def alias named XCD-ROM to point to the external SCSI CD-ROM drive. But obviously it doesn't like the CD-ROM keyword, but seems only to work with the disk keyword, so I'll have to correct the def alias definition afterwards. Anyway, booting up feels more snappy now, and I'm happy to see no further premature crashes. It may not look too comfortable to do a CLI based install, but it's quite straightforward and ever so familiar to me. If you never run Solaris, you may be surprised to see that it reboots already within a few minutes on the first part of the install, as soon as it has finished copying the so-called mini root. From there on, you'll reboot into the mini root on the hard drive, which will run through the remainder of the setup, which includes steps like the basic network configuration and copying the Solaris operating environment. Solaris 9 came with multiple CD-ROMs containing software. At this stage, I'd install parts of the extras and the software supplement. All components can be individually selected if needed. At this stage, you can also define additional file system layouts. It would have been possible to set up this system with a software RAID, but I left that out and went just with a single disk layout, as that's just enough to get going with the actual software install, which will take a good while to complete. Eventually, the machine has finished the base install, and so it's maybe indicated to do some eye candy, as all CLI is quite boring. So I enabled SSH and created a TPC account so I can SSH into the machine. The -X argument enables X11 forwarding, which also needs to be set in the SSHD config file accordingly. That's necessary because, as mentioned before, this machine doesn't have a dedicated graphics hardware, so all there is to use X11 forwarding for graphical applications. As my client runs on Mac OS, I had to install Xquartz as an X11 display server. I did that to show you the companion CD-ROM for StarOffice that came bundled with Solaris 9. You see how it's mounted already to /CD-ROM/Office 6.0. Solaris by default runs the AutoFS auto mount daemon, so drives will automatically mount. So all I had to do was to navigate into the StarOffice CD-ROM directory and run the setup from there. Yay! Installing StarOffice through an X11 remote session. It was quite a lengthy procedure, but eventually I have it up and running. StarOffice 6. The bundled companion CD also includes a good amount of contemporary open source software packaged for Solaris 9. It does have a graphical package installer, but somehow I couldn't get this one to run through a remote X11 session. But it's no big deal, as when you're navigating into the packages directory, you can easily install any package you like from the CLI using the pkg add command. Using this method, I installed a lot of add-on packages, especially graphical applications, some well-known window managers, including the K-Desktop environment and GNOME, where for the latter I could actually use the graphical installer. Now, why bother installing all that graphical bloat if the server doesn't have any graphics hardware anyway? Well, after all, it's a server, right? And when you install XVNC, you can have actually a full-featured X11 desktop via VNC. All you have to do is to add XVNC to the /etc/dt/config/xservers file. If that one's missing, copy it over from /user/dt/config. So here's how I added XVNC, while I also disabled the default Sun X server. Then repeat the steps for the /etc/dt/config/xconfig file, for which you'll find the default template likewise in /user/dt/config. Make sure the grep server statement is set as shown. Then restart TDLOGIN and tail on /var/dt/x errors. If all is fine, you should see an XVNC startup message after a few seconds. Now you can remotely log in via VNC Viewer to port 5901. And the way this works has TDLOGIN still in control of the X11 session, so you'll be presented with the default login prompt. This allows you to experience the default common desktop environment in its full glory. As you saw, I initially configured just an XVNC server with a 1024x768 resolution. But you can actually run multiple in parallel with different resolutions and just use a different TCP port each. Of course, running through XVNC doesn't give the full multi-user experience. It's good enough for demonstration purposes and maybe remote maintenance, but not much more. And it's actually not really secure, yeah, be warned. Still, we can glimpse around a little bit, like here on Sun's management console. It provides access to many system parameters, these system logs, and even lets you handle some hardware related tasks like here to initialize a hard drive. The common desktop environment wasn't actually unique to Solaris, but was a joint development by Sun, HP, IBM and the Unix System Laboratories. Given its release in 1993, it looked quite dated even for 2002 standards when Solaris 9 was current. That's also why Sun eventually bundled a preview of GNOME as an optional component with Solaris 8 onwards. Once you install the GNOME preview, TDLOGIN will provide you with the option to select it as an alternative desktop environment upon login. Since I'm running this thing through VNC, I experienced some distortions with the window decorations. But changing to a different frame style fixed that, so I could fully experience GNOME 1.4, which definitely gave Solaris a more modern desktop appearance. Compare that to the other window and desktop managers of the time that can be made to run on Solaris, whether that be the full-blown K desktop environment or the rather minimalistic TWM. And where FWM2 mimics the appearance of the Windows 9 X UI, Window Maker is more reminiscent to NextStep and OpenStep, Next operating system that eventually became Apple's Mac OS X and which we'll have a look at in an upcoming episode. Last but not least, here's also XFCE, which, like the others we've seen so far, is still under active development today. So, with what you've seen so far, I'm ready to explore more into Solaris because, for one, did you know that there once was a version of Microsoft Internet Explorer for Solaris? And look at this. This is a terminal client, the Sunray one, that I had acquired earlier this year. So Sun did produce thin clients. What for? We're going to find out in my next episode.
Wait a second, what's up with the story about IBM's AIX?
Don't worry, we'll get to AIX on the IBM PS2 soon. But that stubborn beast really bugs me for not booting up at all. Anyway, I'm the Vintage Collector and this was my story for today. If you liked it and want to see more, then please consider supporting my channel with a membership subscription or a gear donation. Thanks for watching and see you again next Sunday.